Good afternoon, everyone, and welcome to the CME webinar on spotting algorithmic opportunities in the energy market. My name is Anthony Cohen, and I'm the Head of Application Specialist for the Asia-Pacific region at CQG. Today, we'll focus on natural gas futures and how to look for clues in order to find and improve algo trading strategies. Before beginning to write algos and strategies, it's important to look for an indicator or a set of rules that have a true relationship with the market that's being analyzed. Rather than actually looking at the chart and trying to identify patterns, it makes more sense to come up with a tool that we know can be useful for trading that instrument. In technical analysis, there are two main types of indicators: breakout and reversal indicators. If an instrument tends to trade in small ranges most of the time, straight away we know that it doesn't make sense to use any breakout indicator for that particular market. Equally, if we're dealing with a volatile product, mean reversion is guaranteed to be a disaster. If we take the famous Donchian breakout system, which consists of buying on the break of the upper channel and selling on the break of the lower channel, we can see that we have some interesting information. Natural gas, like other energy products, is very suitable for Donchian breakouts, as it will move out of ranges often and quickly. And following a recent webinar, we're also using a particular chart type, which is constant volume bars, mainly because we want to work with data that is less likely to produce false signals, but also because we want to keep some of the dynamics of the breakout, and CVBs are perfect for that. The formula section of CQG will allow us to create long and short entries and exits. Each entry and exit is made of a signal, which is when the trigger occurs, a price, the price at which we're going to be executing when the trigger occurs, and a size, which is how many lots we're going to execute. Here we use a very simple entry, which is the break of the upper band for the longs and the break of the lower band for the shorts. The upper band is defined as the highest high over a certain period or number of bars, and the lower band is defined as the lowest low over a certain period or number of bars. For the exit, we have three conditions, which are either a stop with the distance measured in ticks, the opposite signal, which turns out to also act as a trailing stop, and an exit at the end of the day, just so we don't carry any position overnight. We can see the Donchian channel in light blue on this chart. The green arrows are showing the long entry signals. The green crosses show the long exit signals. The short entries and exits are in red. The horizontal line, green and red lines, show the entry price and the duration. At the bottom of the chart, we can see the stats for the duration of the trade system. These stats are what we're going to focus on to see if we can improve them. Statistics provide information on the quality of the strategy. Often, some of the stats are either misread, misinterpreted, or purely ignored. Let's look at some of the most important ones. Total trade count. As useless as it may seem, this is perhaps the first most important stat there is. This represents whether your findings are worth looking at. If you analyze data over 40 years and design a strategy that only trades 120 times, you have a system that trades once every 4 months. The sample of trades is too low to be representative. Total profits are important for obvious reasons, but they're not the only thing that we want to be looking at. Profit-loss ratio, simply the total profits divided by losses, and we're really trying to achieve something in the region of 2 to get a good system. Remove to neutral indicates what percentage of the highest winning trades make your P&L. If you were to remove that percentage of winning trades, your P&L would go to 0. Looking at the graph above, we can see the individual profit and loss distribution. Our losses are limited due to a hard stop, but the profits are not. A remove to neutral value of 10 or 10% would mean that out of about 400 winning trades that we have here, if we were to remove the top 40 trades, the ones on the right, our P&L would go to 0. The maximum drawdown is shown in red here, and although we have a P&L curve that's going mainly upward, there are a few instances where we can see deviation from the maximum P&L. It can easily be ignored, but if it occurs in the middle of your P&L curve, in real life, you can be guaranteed that you will be going through the drawdown straight away when you start trading your system. So it's best to minimize and pay attention to them. The maximum drawdown duration is also important, as it shows how long you can expect to be in a drawdown for. Average profits, that's the result of the total profit divided by the number of trades. It'll tell us how much we're making on a per trade basis. We look at it to measure how slippage is potentially going to impact our P&L. If your system makes good profit on a very large number of trades, and that the average profit is only 1 or 2 ticks worth of the contract size, if you miss either the entry price, the exit price, or even both, your system will flip from positive to negative. And this can be very frequent on natural gas or crude oil because the markets can actually be very volatile. Optimizing is a process that allows the user to test a large number of variable combinations. It's a key process in the backtesters tool. Not because it allows you to find which variable works best, but because the 3D chart that it produces tells a story. It shows the robustness of the strategy. The perfect system has the lowest number of parameters, even potentially none at all. But during the strategy building process, the optimization can be used to find out where to focus on. Not necessarily which values to use, but perhaps which values are useless and which are critical. The aim here is to try and make our system a little bit more robust for natural gas. We know there's a lot of trades, and the beauty of the Duncan channel is that we know that if we increase the period, maybe, we'll have less trades for the same sample of data. The stop distance is also has an impact on the number of trades because a stop that is too close to the entry price is more likely to get triggered more quickly. So instead, we could try and change those values and see if we can impact on the number of trades. In our sample system, the variables are the period of the channel and the stop distance. And we're keeping the number of variables low on purpose to avoid curve fitting as much as possible. So we're going to see how our system behaves if we change the values of the period from 10 to 30 in steps of 2, and the stop distance from 10 to 30 also in steps of 2. So the results are represented as a table, and we can see that right now the optimizer is running through all of the combinations between the two parameters and all the start and end values. We'll see the same list of statistics that we saw earlier, and this process will help us build a 3D graph. The 3D graph shows the exact same data as the table, but it plots our two parameters, which are the stop and the period, against one of the statistics, and we're looking at the average profit here. The area in red shows the highest P&L, while the lowest is in blue. And we can see that the highest profit per trade is found by increasing both the period and the stop distance. But mostly we're interested in the smooth aspect of the results. We're trying to see that there's a proper convergence of values rather than a series of peaks here and there, which would imply that we found a series of random good results. Compared to the original results that we see here, the optimization tells us that we can use a longer period and a stop that is a bit more distant to the entry price. And we've managed to improve the overall P&L, which is good, but also the drawdowns have diminished and our profit per trade has been multiplied by 3. So by carefully choosing the appropriate method and doing simple work on it, we can easily improve a strategy. This concludes this presentation, and I'd like to thank you all for your time today.